guys, it's Dr. White. Welcome to iScience Live. I'm so sad that we're not able to be together in person, but through social distancing, I'm hoping that we're able to stay safe and still share some of the great science activities that I have for you. With our show today, your personal safety right in front of me is not a concern, but I am concerned about your safety if you try to replicate some of these activities at home. So rule number one, don't try it at home. Now there are a couple activities where there are exceptions and I'll point those out to you, but I don't want you trying these activities at home unless you have some help from a parent or a guardian. Some of the equipment that I'm using you might have at home, but your folks might be upset with you if you do some of the stuff that I'm going to do with that equipment, like cut holes in it and run stuff all over it. So please don't do that. So rule number one, don't try it at home unless I tell you otherwise. And then rule number two, I'm not a magician. I may be wearing a fancy coat, but I am not a magician. I am a scientist, and everything that I'm doing today is not magic, it's science. In fact, that's my catchphrase. It's not magic, it's science. So that's rule number two. Now, we're doing this live in my garage. I'm filming this live in my garage, so you might hear some noises and might hear a dog barking and those kind of things. Just want you to know what's going on with that. But I'm very excited to be sharing this with you. My daughter Emily is actually behind the camera filming this for me, so very thankful for her for that. But let's get started and see some science, okay? So Emily, we're going to start with this activity here. If you'll, I'll show you. This is a Diet Coke can, right? And you can see behind it, there's steam coming out of that. That steam is hot, and scientists know that hot things tend to expand. And in this case, it can't expand out or to the sides or anything. It can only expand out through the top of the hole here. So as that steam is rising up inside the can, it's filling the can up with hot steam. What I'm going to do is I'm going to take this can and I'm going to flip it over into this cold water here. And when I do that, that cold water is going to cause the steam to condense, which will cause a little tiny vacuum to form inside of the can. That means that the pressure outside the can will be greater than the pressure inside the can, and something interesting is going to happen to the can. So let's take a look at it. Here we go. Let me get this set up just right. All right, 3, 2, 1. So now you can see that the can has been crushed. And the reason the can has been crushed is because the atmosphere outside the can was greater than the atmosphere inside the can. You can see all of the little crushes here. I couldn't crush it that way with my tongs because I could only crush it on one side. So this is the atmospheric pressure pushing in on the can like that. I got another example of the same kind of thing. Let me show you what I'm talking about here. So I've got this vase here with a water balloon, right? And this vase looks empty, but it's actually full of air. And watch, I'm gonna fill it up for you. So it is full of air, which, because it's full, when I try to push the balloon down in there, it can't go in because the air is blocking it up. Now that's hard to understand because this, it doesn't look like anything's in it, but like if it was full of dirt or sand or something, as I tried to push the balloon in there, you would know that the balloon can't go in because it's full of sand. Well, this is full of air, so I can't push the balloon in there without popping it. So what I'm going to do, though, is I'm going to use a little bit of science, and I'm going to do what looks like a magic trick. But remember, it's not magic, it's science. So what I'm going to do, I've got this paper towel here, right? And I'm going to set the paper towel on fire. I'm going to put the paper towel down in the vase, and then I'm going to put the balloon on top. So as I'm doing that, something interesting is going to happen. So let's take a look and see what happens. All right, so here we go. My paper towel is on fire. And there we go. The balloon looked like it got sucked down into the vase, but it didn't get sucked down in there, it got pushed down in there. Remember how I told you about it on our can, that the atmospheric pressure crushed it from all sides? Well, the atmospheric pressure is pushing all different directions, including down. So what happened with this, as I put the hot paper towel inside of the vase, that warmed the air up inside of the paper towel, which caused the air to expand. Now, the only place it could go was up, and that was where the balloon was. If you notice that the balloon started jumping up and down, and when it started jumping up and down, the air was pushing the balloon up and out of the way. it would push up and out of the way, and then the balloon would fall back down. So over time, a little bit of air came out of the vase, which allowed there to be less pressure inside the vase and more pressure outside the vase. And so the atmospheric pressure pushed the balloon down into the vase, which I think is pretty cool. Okay, so let me show you another one here. I know a lot of y'all are disappointed this summer because some of your fireworks may have been canceled. They were in my town, and I'm assuming they probably are where you are. So I've got a little activity here that you can do that can replicate the fireworks. So what I did with this, I've got a little mason jar here, and you can use any kind of clear glass or anything like that. I filled it up with water, and then on the top, I put a little bit of cooking oil, okay? And you know that oil and water don't mix. What they mean by that is that oil and water will separate out, all right? The oil is less dense than the water, so it sits on top. Well, what I'm gonna do now is I'm gonna add some food coloring. And the food coloring is water-based. So that means it's heavier, it's gonna be denser than the oil, and so that means that it's gonna sink when I put it in there. Well, if you watch, something interesting will happen here. Put a little blue in there, a little red, a little green, and look, you're starting to see the food coloring drop through the oil and spread out inside of the vase. To me, it looks like fireworks. Now, if you wanted to make this happen a little bit faster at home, you could take an Alka-Seltzer tablet and put it in the water, and it'll cause the bubbles to come up and turn all of this over, making like a little lava lamp. But I thought this one was pretty cool doing it this way because it does kind of look like fireworks in a jar. All right, so let's move on to the next one. Okay, so for our next activity, I love doing fire stuff. So and if you guys have seen me before, you know that. So what I'm going to do with this one is we're going to put on some fire and put it out using science. So I'm going to light my candles here, right? And you guys know that the flame always goes up, and it always goes up here on Earth because of gravity. The flame is heating up the air around it, so it expands and it can go upwards. In space, flames don't look like that. They're actually just spherical, which is kind of cool. All right, so now what I'm going to do, we said we're going to put this out. So got a little baking soda here. Gonna shake some baking soda down into my container. All right, and then I'm gonna add some vinegar. You guys know what happens when I mix vinegar and baking soda. You see I'm getting some bubbles here. The bubbles indicate that there's a chemical reaction going on in there. And that chemical reaction is producing a new substance called carbon dioxide. It's the stuff that you breathe out. Now, carbon dioxide is heavier than air, so it's gonna sit in my vase. Now, if I go over here and pour it out, I should be able to pour out my flame there. I'll do it one more time. So my flame went out. So for our next trick, let me show you what I got here for you with this one. I have got a special piece of equipment here. This is a flask. Scientists use the flask to mix solutions together. You can see here on the side, it's got lines for the volume there. And I'm gonna put it on my hot plate here. And if you get real close to my hot plate, you'll notice that there's something interesting on this. This one has a stir function. So in the white part here, there's a magnet. And rolling around inside my flask here, you can see that there's a little thing, it looks like a little pill. That pill is a magnet. So when I turn this stir function on, it turns a magnet in the white part here, and that magnet pushes the magnet in the flask and turns it around and allows me to stir things up. This is a great way to make chocolate milk, by the way. So now you can see this little vortex that's forming in there. That shows me that I'm mixing the stuff up here. All right, now what I'm gonna do is I'm gonna add some of this chemical. Oh, not the right chemical. All right, so I found the right chemical now. So this is universal indicator. And what universal indicator does is it changes color based on the pH of a solution. So what I'm gonna do is I'm gonna pour some of this down in there. Now, normally it's green when as you'll see it coming out of the top there. So it's green, I pour it down in there, and you notice that my solution turns green. All right, now what I'm gonna do is I'm gonna add a little bit of this stuff. This is milk of magnesia. Milk of magnesia you might take if you have a stomach ache. And what it does is it neutralizes some of the acid in your stomach, which causes your stomach to hurt. All right, so this is a base, which is the opposite of an acid. So what I'm gonna do is I'm gonna pour some of this into my flask here, and something interesting is gonna happen. So you see how it's turning purple, right? That purple indicates that the solution is now basic, right? Well, what I'm gonna do is bring back our friend vinegar. Vinegar is an acid. When I add the acid to the solution here, something interesting happens. I love this demonstration because it matches my outfit, right? So what you're seeing now, the orange and yellow color indicate that the acid in the solution is taken over. It is neutralizing the base that was in there. Now you'll notice it'll start going back the other way. Now it's going back to green, which means it is neutral pH around 7, and then it's going to go back to bluish purple, which indicates that it is a pH above 7. All right, well, if I add a little bit more vinegar, we should see the reaction happen again. I just love this. Seeing it all swirling around and everything. All right, again, so the pH here is less than 7, indicating that it's acidic, and this is going to keep going back and forth as the acid and the base are interacting with each other. I love that, right? I think that's so cool. All right, now I want to show you one more example of something with a vortex. All right, so I'll turn that on. Bring out my vortex machine here. So what I got, this is a trash can, and it has holes in the side of it. The holes are very important. Inside of the trash can, I've got a dish, and in that dish, I put some alcohol, okay? I'm gonna set all of this on this piece of equipment here, which is, this is a Lazy Susan. So it just spins around like that. I love this. Anything with the word lazy in it, I'm a big fan of. All right, and so what I'm gonna do is I'm gonna set the alcohol on fire here, right? And you guys again notice that the flame is rising upwards, right? That's because it is warming the air up, making it less dense, and less dense things tend to float upwards. So then what I'm gonna do is I'm gonna take it and give it a spin, and something interesting is gonna happen. So I've got a little fire tornado going on in there, which is really cool. We're in the middle of tornado season right now, right? And tornado season happens because the air closer to the ground is warmer than the air above it. So the warm air rises and the cold air falls, and when they meet in the middle, it causes a disruption. The air becomes unstable. And then if you get a little bit of crosswind, that'll cause the rotation to start. So let's watch one more time. I think that is super cool. That is my fire tornado. All right, now I have to be real scientific with how I put it out. So, all right, now I got one more thing that I want to show you here. This one is an optical illusion. Okay, so I've got an arrow here, and that arrow is pointing that way. Now I'm gonna set a glass in front of it. And I'm gonna fill up the glass with water, and I want you to watch what happens to the arrow. Can you see it? The arrow has flipped sides. So what's happening is, as the light comes into the glass, the water bends the glass, okay? So there's light coming that's bouncing off of the arrow and coming out towards you. That's how you see it. Well, what you would normally see with the arrow going this way, this light is coming directly to your eye, this light is coming directly to your eye. Well, here, when we pass it through the water, this side light that comes through there runs into the glass and gets bent and comes up to the opposite direction. Same thing here, opposite direction. You know how when you are riding in a car and you hit a puddle in your car on one side of it and it causes the car to turn in that direction? That's what's going on here. The light waves that are coming off of the arrow are running through more dense material, the water, and that is causing them to bend. So I thought that was pretty cool. That was definitely something you could try at home. Try it with other things and see if you can get to spell words backwards and those kind of things. Okay? I've got another demonstration I want to show you here, which I love this one. It's one of my all-time faves. Okay? So, with this one, got some interesting things going on here. So this is a graduated cylinder. It's graduated because it's got these lines on front of it, right? And this allows us to measure stuff. This one's a 1 liter graduated cylinder, all right? And what I'm gonna put in the bottom of the graduated cylinder is this stuff. This is hydrogen peroxide. And this is not like hydrogen peroxide that you have in your underneath your sink in your medicine cabinet or something like that. The stuff that you have is 3% hydrogen peroxide. This stuff is 10 times stronger. It's 30%. All right, and so what I'm gonna do is I'm gonna pour it in here. Now you guys know when you put hydrogen peroxide on a cut, it bubbles up. Turns out that hydrogen peroxide is a great bubble maker. All right, well, you know that if you wanna make bubbles and have them last, you need something to catch the bubbles. So what I'm gonna do now is I'm gonna put some soap in there. And the soap will help catch those bubbles. Put a little soap down in there. And just for fun, I'm gonna put some food coloring down in there to make it easier to see what's going on. Take it and swirl it around there so you can see now I've got my my hydrogen peroxide, kitchen soap, and food coloring mix. Now what I'm gonna do is add this chemical. This chemical is called potassium iodide. Potassium iodide is a catalyst, and what it's gonna do is gonna make all the bubbles come out of our solution all at once, rather than just a little bit at a time. So, well, something interesting is gonna happen. I just want you to see it. So let's take a look and see. All right, here we go, ready? Don't do that. Here we go, ready? 3, 2, 1. Get in nice and close on this one. 3, 2, 1. So you can see there's bubbles coming. Ah! Those are bubbles. You see all the steam coming off. That is water vapor. There's oxygen being produced. We know that there's a chemical reaction going on here because we can see the bubbles. We can see that there's a new substance being produced, and you're just getting a nice oozy kind of pile of foam here. My high school students used to call this elephant toothpaste, and I think you can kind of see why they call it elephant toothpaste. So it's just bubbling over here, which is so much fun. I love this. I love this. One of my favorites. All right, so I've got a couple more things that I want to show you. One more thing that I want to show you is my Vortex cannon. All right, and you remember when I told you don't try this at home, was rule number 1? All right, this is one of the prime reasons I don't want you to do it. This is a trash can, and I cut a hole in the bottom of it. So what's the trash can full of right now? It's full of air, okay? All right, and so what I'm gonna do, right, you can see me in there. All right, when I take this trash can and put the lid on it and hit the back of it, it's going to push the air inside the trash can out that hole. And something interesting is going to happen. So what I'm going to do here, Emily, if you want to back up a little bit, I've set up a piece of paper here on my ladder so you can see what's going on here, because this creates a vortex. And that vortex will spread across the space pretty awesomely. So what I'm going to do now is I'm going to take it and hit it. Ready? 3, 2, 1. So you saw it knocked my paper off. It's kind of hard to see what was going on with that because the air is invisible. So what I'm going to do now is I'm going to add a little bit of smoke so you can see what's going on. Now you may have heard some beeping going on back here. The beeping is my smoke machine. So I'm going to add a little smoke to it. Of course, it's not going to work now. My smoke machine is working, I think, so we'll try it again. All right, so spraying some smoke into the hole down here. All right, so now my machine is full of smoke here, my Vortex cannon. And so what I'm going to do, so that you can see the smoke ring, so you can see the vortex, I'm going to blast it right at the camera. So here we go. 3, 2, 1. Back up a little bit. So you can see when I hit the back of the vortex cannon here, it pushes the air out through that hole, causing the air to squeeze because the hole is smaller than the diameter of the trash can. So that causes it to squeeze out. And then as it comes pushing out through the hole, it sticks to the side of the hole, and that's what causes it to kind of start spinning around. This is called a toroidal vortex. I call it awesome. All right. So, got one more thing to show you here. Emily, if you'll pause right here. Okay, now I've got my equipment set up here. You can see I have an interesting contraption here. All right, so this is a leaf blower. And to my leaf blower, I've attached a paint roller. And to that paint roller, you can see I've attached two rolls of toilet paper. Now, a couple of weeks ago, I wouldn't have been able to do this particular experiment because toilet paper was so valuable. This is the cheap stuff, so I don't feel so bad about getting rid of this. All right, but what I'm going to do is I'm going to turn on my leaf blower, and as I turn on my leaf blower, the air is going to come out and push over the top of these two rolls of paper. This is very similar to what happens on a airplane wing. As the air goes over the top of the curved surface, it speeds up. And as it speeds up, it gets less dense, which causes an area of low pressure to form over the top of the wing. As that low pressure forms over the top of the wing, there's more pressure underneath, which will cause it to rise. So what you'll see here is our toilet paper will take off like an airplane wing. Okay, are you ready? 3, 2, 1. Are you in there? All right, let's get you out of that. All right. Well, guys, that is it for iScience Live today. I hope you enjoyed our little science activities that we did. I hope you learned a little bit, and I hope this encourages you to study science and keep on learning about the world around you because it is fantastic. So just remember the 2 rules we have for the show. Rule number 1, don't try it at home. And rule number 2, it's not magic, it's science. Thanks for joining us today.